Section 9.7 is special functions. So we're going to be looking at step functions, which are a series of line segments put together. And so because they're lines, we call these piecewise linear functions. So the first function that we're going to take a look at is the greatest integer function. Okay, and this one will actually look like steps. So the notation is f of x equals, it looks like some double brackets here. What that means is that it's the biggest integer not greater than x. So here's an example of this one. So if I wanted to find the greatest integer function of 5.2, it means I want the whole number that's not bigger than 5.2. So 5.2 is in between 5 and 6, but it can't be bigger than 5.2. So this one would be 5. Okay? Or if I have, let's do the greatest integer function of 6.9. Yes, 6.9 is closest to 7. However, it can't be bigger than 6.9. So this is also going to be 6. It just can't be bigger than that number. Okay? The only time you really kind of have to be careful with these is if you're dealing with a negative number, because then it's kind of backwards. So just be mindful of that. Okay, so we're going to go ahead and we're going to take a look at our first example here. So if we have f of x equals the greatest integer function of x plus 2. Okay, I'm going to go ahead and I'm going to pick just a bunch of numbers. Okay, and we're going to go ahead and we are going to plug these in. You could pick all whole numbers. I'm going to pick some decimals because it's going to make it a whole lot easier for you to see the steps. Okay, so for example, I might have 0, I might do 0.25, I might do 0.5, I'm going to do 1, I could do 1.5, I'm going to do 2. If we need more, we can go ahead and we can add some more in there. And actually, I'm going to go ahead and I'm going to change this from a y up here. Okay, I'm going to go ahead and I'm going to say this is what x plus 2 is. And then I'm going to say, well, this is what the greatest integer function of that is. Okay, so if I plug in 0, I'm going to get 0 plus 2, which is 2. Okay, so the greatest integer function of that is 2. It can be equal to that, but it can't be bigger than 2. Perfect. Okay, if I plug in 0.25, I'm going to get 2.25. Remember, the greatest integer that it's closest to, can't be bigger than it, is 2. Same thing here. I'm going to get 2.5. The greatest integer here is 2. Yes, it's in between 2 and 3, but I can't go with an integer that's bigger than that number. If I plug in 1, I'm going to get 3. And so it's going to be 3. If I do this, I'm going to get 3.5. So it's also going to be 3. If I plug in 2, I'm going to get 4, and I'm going to get 4. Now what we're going to do is we're going to go ahead and we are going to graph it. Okay, so here is where it gets a little bit confusing. The start of your line is always going to be a solid dot. The end is always going to be an open circle. Okay, so let's go ahead. So we're going to say if I start at 0, I'm going to get 2 out as an answer. Okay, so I have a closed circle there. Anywhere between 0 and 1, my answer is going to be 2. So from 0 to 1, I have an open circle at 1, my answer is going to be 2. But once I get to 1, my answer is actually 3. So anywhere between 1 and 2, my answer is 3. If I go to the next one, anywhere between 2 and 3, if I kept adding, my answer would be 3, and I would keep going on, or my answer would be 4 rather. And I'm going to keep going on and on like that. As long as you have 3 little steps on your step graph, that's perfectly fine with me. If I was going to talk about the domain and range of these, the domain, again, is all reals. I can always plug in any answer. My range for these is that it has to be an integer, so all integers. I can't get a decimal out in that last column, so it has to be integers. Okay, so our next one are absolute value graphs, and absolute value graphs are similar to quadratic functions in the fact that they are symmetric. However, instead of being used this time, they are going to be V-shaped graphs. So it's really important that you curve the bottom of your quadratic ones and you make these ones come to a point. Okay, so same thing, we're going to make a table for these. So if I have f of x, this is not working very well. Rewrite that. So if I have f of x is equal to the absolute value of x minus 4. To figure out the middle number in your table for these, you're going to take the part that's in the absolute value and set it equal to 0. So that means that 4 is going to be the middle number in my table. Okay? So I have 4, I might have 5, 6, and 2, 3. Okay, so I'm going to go ahead and I'm just going to plug in numbers. So if I plug in 2, 2 minus 4 is negative 2. The absolute value of negative 2 is 2. If I plug in 3, 3 minus 4 is negative 1. The absolute value of negative 1 is 1. If I plug in 4, I'm going to get 0. And remember, it's going to reflect. So now we're going to go ahead and we are going to graph this. So if we go ahead and graph this, I'm going to go ahead and I'm going to have the ordered pair 2, 2. I'm going to have the ordered pair 3, 1, 4, 0, 5, 1, and 6, 2. I'm going to go ahead, I can connect those like so. It should be V-shaped, it should look like that. Okay, if I'm looking at this, my domain here is all reals. We can plug in any number. And my range, if you notice, I don't have anything added on the outside here, is that y is greater than or equal to 0. All my numbers are above 0. Now let's go ahead and take a look at our very last example. So our last ones are piecewise defined functions. And what that just means is that there are 2 pieces, 2 or more pieces, that are going to be put together on the same graph. And they're defined because they tell you where it happens. So they're going to give us something and it's going to look like this. So they might say that f of x is equal to negative 2x if x is greater than 1, and it's equal to x plus 3 if x is less than or equal to 1. Okay, so what we're going to do is we're going to go ahead and we are going to graph this. Okay, so I'm going to look at just the first part of this. I'm going to look at this first statement right here. So it says I'm going to start at 1. Because it's not or equal to, that means I'm going to have an open circle there. If I plug in 1, I'm going to get negative 2 times 1 is negative 2. So I'm going to go to 1, I'm going to go to negative 2. I'm going to have an open circle. My slope, from there, I'm going to go ahead, I'm going to use my slope. So I'm going to go ahead and use my slope. From there is negative 2. So from that point, I can go down 2 over 1, down 2 over 1, and I'm going to draw an arrow. Now I'm going to go ahead, I'm going to look at the other part. It says x plus 3 if x is less than 1. Less than or equal to 1. So I'm going to go ahead, I'm going to go and plug in 1. If I plug in 1, I'm going to get 4. Because it's or equal to, remember, I'm going to have a closed circle. Now, I'm going to pick numbers that are less than 1. I can plug them in, I can use my slope, but I want to be going down. So, for example, if I plugged in 0, I'm going to get 0 plus 3 is 3. Or I'm going to get, if I plug in negative 1, I'm going to get negative 1 plus 3 is 2. Okay, so it should be a line that goes down this way. It doesn't matter which way you decide to do it. Just make sure that you go ahead and do them that way. So that is your graph. It's just going to be 2 pieces. That's why it's a piecewise graph. So here, I'm going to say my domain, again, is all reals. My range is a little bit harder to see this time. Both of my graphs are going down, so it's never going to be greater than 4 here. So it's y is less than or equal to 4.